All right, 2.3, discussing slope and rate of change today. Okay, again, this should be a concept that is familiar to you and that you have heard before in Algebra 1. So we should be able to move through this relatively quickly here. I'm just going to adjust these lines a little bit because they're off a tad here. Okay, so when we talk about the rate of change, that is just another phrase for slope. And what the rate of change does is it measures how much one quantity changes relative to another quantity. Okay, so you're probably the most familiar with slope in thinking of it maybe when you were first introduced to it as rise over run. Okay, and if you think about an x-y axis and you think about which axis is the one that rises up and down, that's the y-axis, and the one that runs back and forth is the x-axis, you can see how in the formula for how to get the slope through 2 points, you'll notice the y's are being subtracted in the numerator, which that kind of agrees with the fact that we say rise over and then run is in the denominator. The x's are in the denominator. Again, that's the axis that would run back and forth, left and right. Okay. We are going to go ahead and skip this first example, move on down to example number 2 here, where it mentions the table shows the temperature of a solution after it has been removed from a heat source. It's asking us to find, and when you see this phrase, rate of change, you just need to think to yourself, okay, this problem is asking me to calculate the slope. Okay. We're looking for the rate of change in temperature for this solution. And so what you have over here in the table, and you can always assume when you're given information in a table like this in columns, that the leftmost column are the x coordinates and the right column, those are the y coordinates. And so essentially we have 5 points here. Okay. All of these particular graphs are all linear in nature. So you technically only need to choose 2 points. You can pick any 2 points you like. I will tell you anytime you have the opportunity, though, to choose a point that has 0 as one of its coordinates, it does make the formula a little bit easier. Okay, I'm going to go ahead and scroll so that we can see the formula up here. Okay, I'm going to highlight that. Here is the slope formula. It is something that you want to make sure that you commit to memory. You might be familiar in math. A lot of times we use the variable m to represent the slope. Okay, so we're going to be subtracting the y values, and then we're going to divide that by the difference in the x values. I just chose the first 2 points in this table. You could pick any combination of 2 points in the table. I'm going to go ahead and subtract the y values. Okay, it doesn't matter the order you subtract these y values, provided that when you go to subtract the x values, you do it in that same order. Okay, so when I do this, it looks like I'm going to end up getting negative 2.1, and then here's the really important part. You need to make sure that you are labeling your answer. Okay, so in order to do that in the context of these problems, you need to pay attention to what is the y coordinate for that particular problem, and we can see over here that the y coordinate is temperature in degrees Celsius. So when you're labeling this, you always want to put the y coordinate in the numerator and then draw a little division bar and then put whatever the x variable is in the denominator. Okay, and our x variable is time in minutes. So this should get labeled degrees Celsius, and then we read that division bar as per, and then we put minutes down here. Okay, so this means the change in temperature, they've removed this from a heat source, it's losing 2.1 degrees Celsius every minute. Okay, that is the rate of change here. Okay, let's go ahead and move down to example 3, which you can see has been completed for you on the notes page. A lot of times what happens with these problems is they are all asking you to do the same thing. They all want, even just if you see just the phrase rate and it doesn't say rate of change, that is simply asking you for the slope, but they do tend to present the information in different formats. Like the example we just did, they gave you several points in the format of a table. In this example, they're giving you the information represented as a graph. Okay, it says the graph at the right shows the number of gallons of water in a swimming pool as it is being filled. At what rate is the pool being filled? Okay, so what you would want to do is simply go through and choose 2 points on the graph. They made it really easy for you because they went ahead and labeled 2 points for you, and then plug those into the slope formula just like we did in the previous example. Okay, please note that I labeled this gallons per minute. Gallons is the amount of water that was the y coordinate, and minutes is the time variable, which is the x coordinate. Very important on the word problems that you're always labeling them, and it is y coordinate over x coordinate. Okay, let's move down to example 4, where we find ourselves kind of having 2 problems in one. I'm going to read through this problem. It's going to sound like there's a lot of numbers initially, but if we organize this well on our paper, this actually is pretty easy. It says in the year 2002, there were 23,142 students who applied to State College and 34,689 students who applied to Central University. To make this easier, I'm going to go ahead and highlight these. For 2002, we said there were 23,142 students that went to State College, and then 34,689 who applied, rather, to Central University. Okay, then it goes on and it mentions, so that was for the year 2002. In the year 2010, there were 29,563 students who applied to State College. But in that same year, 36,107 students who applied to Central University. Okay, here's the phrase that you're looking for. Determine the average rate of change. That just means find the slope in applicants for both schools from the year 2002 to the year 2010. Okay, so here's what we're going to want to do. Let's go ahead and organize our paper here so that we have State College over here on the left. Okay. So I'm going to make 2 columns, and then we're going to call this one over here Central U for Central University. Okay. A lot of times when they give you points, but it's not in a table and it's not in a graph like the previous 2 examples, but rather it's listed out in sentences like this, you're just going to pair up the first number that they mentioned for State College, and you're going to use that as the X, and you're going to pair that up with the second number they mentioned for State College as the Y. Okay, so our, oh, I'm sorry, that is incorrect. I apologize. Okay, all right, so our first number that they give us is the year. That's the year 2002. Okay, that's going to get paired with the number of applicants for State College. So our first point is 2002 paired with the year, or with the number of students, 23,142, okay? And then just talking about State College here, the next one we're going to use as our year, 2010, and that's going to be paired with the number of applicants at State College. So there's my 2 points for State College, and then my 2 points for Central U. Again, the years are going to be the X coordinates, but I'm going to pair those up with the number of applicants for each. And so that you can see this is really just 2 problems in one, okay? And we're just going to go through, and for State College, we're going to go ahead and subtract the Y coordinates. Again, the order that you subtract these in does not matter, as long as whatever the order is that you use for the Y's in the numerator, you use that same order when you're going and subtracting for the X's in the denominator. Okay, I want you to think about how this should be labeled. Okay, this is, we always want to label this our Y variable per our X variable. So let's think about what the Y variable was. It was these numbers right here. These represented the number of students or number of people, and then our X variable was the year. Okay, so you could either say people per year, you could say students per year, or you could even say applicants per year. Okay, so at State College, between the years 2002 and 2010, they were looking at an increase of about 802-ish students or people per year. Okay. If we were to essentially do that same thing over here for Central U, okay, again, subtracting the Y's from the top, the X's in the bottom, we end up getting for Central University 177.25, again, same label, people per year. Okay. All right, let's go ahead and flip on here to the back. This is an example that several years back, the state of Ohio was going to make an end-of-course exam for Honors Algebra 2, and then they released some questions that they might put on the test, and then they decided that they weren't going to do that. But number 5 and number 6 are both really good questions that they had released that kind of fit into this. So I want to go ahead and read through this with you. It says, an investor deposited $5,000 in an account. It earns 1% annual interest. The amount of money in the account is represented by this function. Okay, so here's our function. Okay, so what's important to keep in mind is, what does the x in this equation represent? And they tell you right here, where x represents the number of years since the account was open. Okay, and I will tell you the y, that is representing the amount in the account. Okay? Now, keep in mind, all of these problems are the same. They're all really asking you to just use the slope formula. And so the question is, what is the, okay, there's our phrase here, average rate of change. What is the average rate of change between x equals 2 and x equals 7? Okay, this is kind of like a multiple choice. There would have been this drop-down menu here. This is the slope, and then this, they want you to choose one of these 4 options for how it should be labeled. Okay, so just because you would choose one letter doesn't mean the label underneath it would be the label that you would choose per se. Okay, so let's go ahead. I like to write out these as points. We've got 2 x values, so I'm going to plug the 2 and the 7 in, representing the number of years since the account was open. Now you'll notice they don't give us the y value. Okay, so what we need to do in order to get the y value for these is we need to take these x values and we need to plug those into this equation for the x. So if you were to go to your calculator and type this in and plug 2 in for the exponent, you would end up getting 5,100.5. And if you went back and did the same thing with the 7, you would end up getting, 5,360.68. Okay, now we have our x and our y values. So we're going to go ahead and subtract the y's in the top, x's in the bottom. That gives me 52.04. I'm going to circle C, and then I need to pick a label. I want to think about what's my y. That's the dollar amount. So I want dollars to be in the numerator per, I want my x to be in the denominator. That would be the number of years. So I'm looking for dollars per year. I would choose this label to go with that. Dollars per year. Okay. All right, let's go ahead and try number 6. It is very similar to number 5. Number 6 says that the population of country A was 40 million in the year 2000, and it had grown continually in the years following. The population P is in the millions, okay? So our y variable represents the population in millions of people, okay, millions. The T is the years after the year 2000. So if you were to, T's like your x. If you were to plug in, here's where the T is. I don't know if you can see that. It's right up there in the exponent. Okay. If you were to plug in, say, a 3 for this T, you're really talking about the year 2003. Okay, but you don't plug in a 2003 for the T. T is not what year it is. T is the number of years after the year 2000. So with that in mind, let's look at the question. Based on the model, there's the phrase, what is the average rate of change in millions of people per year of the population from the year 2000 to the year 2005? Okay, now 2000, let me think about what the x variable should be for that. Okay. Our x, which is our t, how many years after the year 2000 would have occurred if we're talking about the year 2000? Well, that would be 0 years have passed. Okay, remember, these are our x coordinates. How many years after the year 2000 would the year 2005 be? Oh, that would be 5. Okay, so here's my 2 x values. Then what you're going to do, similar to what we did up here in example 5, we took our 2 x values and we substituted them in for the x on our calculator to get the y values. You're going to substitute 0 in for the t and type that into the calculator. By the way, this E that you are seeing right here, there is a button on your calculator for the E, and that button is under the division key. Okay, you'll see a little e there. Okay, and then in the exponent, you'll put 0.027 times, and then you'll plug a 0 in once, and then a 5 in again. Okay, if we were to do that here, we get 40 for that, and we get 45.78 for this. We're going to go ahead and throw this into the slope formula. Y's in the top, x's in the bottom. This is how I'm going to label this. This should be millions of people per year. Okay, that's how that's going to get labeled, y variable per x variable. Okay, let's bring this to a close with just these few problems down here at the bottom. You can see that I went ahead and did this example for you. It is very much like the one on the front, but you're given the 2 points. I will tell you this, when you are presented with finding the slope, always present the slope as a fraction, okay? Your calculator can reduce that fraction for you if you press the math option 1 button, but we're going to say no decimals when we're doing slope. Okay. All right, so the last two examples, example B and C, they want us to find the slope. They're not really giving us 2 points though, so you won't need to look for yourself. Where are some locations where it feels like this line is crossing a nice place at a corner of a grid so that you can find out what the coordinates are? And I would say those would be two really good places. The other thing you want to be careful of, especially on this example, notice we're counting by a scale of 2s. So this first point right here is not the point 1, 1, that's the point 2, 2. And then this other point over here on the left is the point -8, -2. Okay. All right, be careful with negatives. We're going to subtract the y's in the top, x's in the bottom. I'm going to connect these double negatives here. It's going to give me 4/10, but I always want to reduce my fraction, and I want to keep it as a fraction. Okay, this one, if it doesn't mention anything weird, you can assume the scale's just counting by ones. Okay, I'm going to go ahead and make a distinction of which points I'm choosing. That's the point -1, 2, and 0, -2. I'm going to throw that. You do need to show the work for the slope formula. Don't just type this into your calculator and simply write down the answer. You need to show these steps just as I am doing here. Okay. All right, your homework assignment is worksheet 2.3.